Right now, there are plastic particles floating around us. Nanoplastics so small that they're carried in the air. And we're breathing them in, all of us. And these plastic particles are going into our lungs, crossing over into our blood and circulating all around us. The world is becoming so polluted with plastic that it's becoming inescapable for everyone. Why is this happening and what can we do about it? I've been invited aboard the Santa Maria Manuela by the Tall Ships Races, and from here I'm going to tell you about both. Plastic is an incredible material. It's durable, it's cheap, it's flexible, it's moldable, it's unreactive. We can make it in almost any colour, we can make it in almost any form, and our society, completely understandably, has become totally dependent on it. Sometimes for good things, like in hospitals where it's transformed our ability to help people in desperate situations, but far, far too often for things that nobody needs. We're making about 350 million tons of plastic every year, which is a lot because that's a big amount. And also because, unlike almost all the other waste we produce, this stuff does not disappear. In countries where waste systems are well organized, plastic is swept away, out of sight, out of mind. But this is what far too many of the world's rivers look like now. You can't stop kids from wanting to swim in the rivers. Is this going to be the future of every river? Because that is the path that we are on. Via the rivers and directly off the coast, about 8 million tons of plastic is entering the oceans every year. That's nearly 300 kilograms of plastic every single second. What TF is happening? Every time you throw away plastic, it ends up in a system where a horribly enormous amount of it ends up in the oceans, whether you like it or not. In the LA area alone, 10,000 kilograms of plastic waste like plastic bottles, plastic straws, plastic cutlery, plastic bags, and so on washes into the ocean every single day. It's now almost impossible to walk across any beach in the world without encountering plastic waste washing ashore. This is a friendly turtle, and this is another friendly turtle that, at just the wrong time in life, got unlucky and swam through one of billions of rings from plastic bottles floating around the ocean. Somehow, bafflingly, she survived despite having her organs bent through this tiny space. Imagine the agony of having a body bent like that. This is a baby shearwater bird on Lord Howe Island, dying before it even gets to fly for the first time. And this is what the contents of its stomach looks like. It's literally full to bursting with plastic. It died starving hungry with its stomach so full it couldn't swallow another thing. All of this came from parents trying to help to raise their young chick, bringing back items they thought were food from the cleanest ocean on Earth, the Antarctic. Investigations of chicks on Lord Howe Island found 100% of them to have plastic in their stomachs. Here's a baby albatross on Midway Atoll in the middle of the Pacific Ocean, miles away from most of human civilization, vomiting up plastic. And here's what the contents of its stomach looked like after it died. It's the same story on an even bigger scale. This picture shows the contents of the stomach of a single baby albatross. And this picture shows items found in various baby albatross stomachs. There's everything from toothbrushes to golf balls to lighters. Why on earth are we using plastic lighters when we could be using refillable metal ones? This is Tuvalu, a tiny island nation in the Pacific Ocean where, until 1978, plastic was never used. After that, they started importing goods from Asia, and with that came plastic packaging galore. And now, a nightmare is unfolding. Unlike their waste before 1978, this new plastic waste doesn't degrade and disappear. They can't use it to fertilize their plants, and if they try to burn it, then it releases noxious gases like dioxins and furans. So they've been dumping it in ever-growing wastelands at either end of the island, and the people who live there try to control it by burning it. And these people appear to have cancer rates orders of magnitude above the norm. This little girl is growing up in the middle of this polluted wasteland that is very rapidly becoming the reality in many other places too. And every day, she watches the plastic around her blowing into the ocean. In the ocean, the plastic concentrates in the middle of giant swirling currents called gyres. There's this idea going around called the Great Pacific Garbage Patch. People say that it's an island of plastic 3 times the size of Texas in the middle of the Pacific Gyre. But actually, ideas like this are really unhelpful because they're very misleading. The center of the so-called Great Pacific Garbage Patch actually looks like this. It doesn't look like it's full of plastic waste floating everywhere really at all. The real problem is a lot more insidious. Most of the plastic in the ocean doesn't float in places where it's retrievable and can be cleaned. It sinks. This is why ideas like Boyan Slat's Ocean Cleanup Project, a huge floating barrier filtering plastic off the top of the ocean, won't work. All due respect to Boyan, he's trying to do the right thing, but we're all still impossibly far away from a solution. What does remain on the surface rapidly breaks down into tiny pieces, covering the surface in a thick plastic gloop. Billions of tiny plastic particles. Scraping off all of the gloop would mean scraping off enormous quantities of plankton and algae, and that's not something that we can easily afford to do. Plankton is the backbone of the oceanic food chain, and algae is the primary source of the global oxygen supply. To make matters worse, these tiny particles of plastic act like magnets for loads of dangerous pollutants in the ocean, of which, unfortunately, there are many. In the 1960s, it was legal to pour DDT into the oceans, and people did, a lot, and most of it is still there. These dangerous chemicals love clinging to plastics, and the concentration of these chemicals on the surface of these plastics after just a few hours of them being in the ocean is literally millions of times higher than the concentration in most of the ocean. Tiny microplastics are the worst because they have such a high surface area for these chemicals to cling to, and because they're so easy for ocean creatures to eat. Here's a picture of some oceanic plankton. They think the microplastics are food, and they absorb all the chemicals attached to them, and then they're eaten by everything from fish to basking sharks to blue whales, the biggest animal on Earth. Here's a picture of a fish, also full of microplastics covered in pollutants. This is not an unusual fish, and those were not unusual plankton. This is the norm now. Ocean creatures are full of plastic. And since the ocean food chain is entirely linked to our own, whether we're eating seafood or land animals, humans are right now suffering from the effects of plastic pollution in the oceans. Even the plastic we use has a direct negative health effect on us. It's well understood that polycarbonate slowly leaches a chemical called BPA, which causes ovary damage, decreased sperm production, early onset puberty, behavioural changes, and a weakened immune system. And about 95% of US adults test positive for BPA. PET slowly releases antimony trioxide, which is linked to increased rates of cancer, and DEHP is linked to numerous different kinds of cancer and is known to damage our livers, our kidneys, our spleens, and our bones. Polystyrene leaches styrene, especially when it's got hot food in it, and especially hot oily food. And styrene leads to sexual development problems and can damage our red blood cells, our livers, our kidneys, and our stomachs. The manufacture of PVC produces dioxins, which are the most cancer-causing chemicals that we know of. The news made a big noise recently about plastic-eating bacteria, and lots of people thought that we'd found the total solution to solve everything. But we are so far away from finding a total solution. The plastic-eating bacteria is useful, yes, but it can only digest PET, one of many different types of plastic, and only on a small scale too. So what can we do about this? Firstly, recycling is not the answer. Recycling should be considered a last resort. It's a myth that recycling can go on forever. Generally, plastic can only easily be recycled about 10 times before it starts to become brittle and black. The blackness is a problem because it makes it very difficult to sort the plastic from other types of plastic. So then what? I mean, we could use the black plastic to make roads, but then when the water falls on them, it's going to leach microplastics into the waterway. And also, how much of the world do we want to cover in black plastic before we realise that we've gone too far? The answer is not to recycle, the answer is to stop using plastic. A lot of the plastic that we recycle ends up as something called biosoliid, which ends up in fertilizers often. We literally end up pouring these plastics onto the crops that we're growing. In the UK, where recycling is quite good, about 13% of attempted recycling ends up in landfill anyway, because either it can't be sorted or it hasn't been cleaned properly before being put in the recycling. That's right, in most places you're supposed to make sure plastic is clean before recycling it. Lush do some quite good closed loop recycling. They get all their own containers sent back to them so they know what kind of plastic they're made of, and so they can turn them back into the same containers. Another solution that people talk about a lot is biodegradable plastics, but so many of these are very misleading. A lot of them are just normal plastics in tiny pieces held together by plant material. And for sure, the plant material can biodegrade, but in doing so, it releases all of those microplastics. It's kind of like a microplastics grenade. Polylactic acid is normally made from corn and can actually fully degrade, but even that takes about 4 years, in which time floating bits of it can kill countless marine organisms. It might be better than normal plastic, but it's still a long way from ideal. Another problem with polylactic acid is that if it gets mixed in with normal recycling and ends up becoming part of something structurally important, like a pipe in its next life, then that pipe might then fall apart long before it's expected to. Compostable plastics are also a little bit misleading. Usually you need an industrial composter to break them down. You can't just throw the plastic in your normal compost. It won't break down because the temperature won't get high enough. It's of course a great thing that people are working on alternatives to plastic, but we're still at a point where the best thing that you can possibly do is avoid plastic wherever you can. Every time I speak to food suppliers about plastics, they tell me that they'd love to use something other than plastic to package their food, but there's nothing else that allows them to maintain the standards of hygiene and freshness that are demanded of them by the supermarkets other than plastic. We have to tell our supermarkets that we want our salad leaves handed out, not packaged in tiny little plastic bags. For now, every little helps, from buying bars of soap instead of soap in plastic bottles, and buying butter wrapped in paper rather than in plastic pots. And try to avoid buying plastic bottles whenever you can. Did you know that it actually takes about 3 times more water to make the plastic bottle than it can actually contain? Wherever you politely and friendlily refuse single-use plastic, you're slowly bringing about positive change. It should never be an aggressive thing refusing single-use plastic because it's positive for everyone. The most important plastics to avoid are those that lead to microplastics. Microbeads were banned in the EU in June this year, which is fantastic, but unfortunately these things are now flooding Asian markets. Rather than the manufacturers abandoning them, they're trying to look for new places to sell them. However, microbeads only lead to 1/30th of the microplastics in the ocean. About 1/4 of them come from tyres, even though most of them never go anywhere near the ocean. And 1/3 of the problem comes from us, every time we wash synthetic clothes, because tiny bits of plastic peel off them and head down the drain into the rivers. One of the biggest things that you can do to help with the fight against plastics is to stop buying synthetic clothes. And you can also buy something called a Corable to put in your washing machine that will capture some of the microplastics given off by synthetic clothes in washers. Aside from changing what we buy, we have to reach out to governments. Legislation works. In the first year of introducing the 5p plastic bag charge, usage dropped 90% in the UK. Ideally, we'd be able to classify plastic in the water as hazardous globally so that we can use existing legislation to keep it out and to restore habitats that are being destroyed by it. But we still need to push a lot harder to make that happen, because unfortunately, wherever we are, we're in a world where the air we're breathing contains plastic. It's all over the food chain, it's even in the rainwater, and it's destroying our precious oceans. Thanks for watching, thanks to the Santa Maria Manuela, and thanks to the Tall Ships Races. Check out plasticoceans.uk, spread the knowledge and deliciously subscribe for more.